Hey kids, this is Mr. Cozy, and this is video 37 where we talk about functions and the domain and range of a function. So let's get started. In math, frequently we want to relate numbers together somehow. And what we get out of the process of relating numbers together is called a relation. It makes sense if you think about it. So an example of a relation is -1 is related to 2, 3 is related to 1, the 5 is related to 8, and -1 is related to -3. Okay. Now, typically, we call the first number in each of the pairs x, and the second number of each of the pairs y. Okay, and these are related together for some reason. I don't know why, but for some reason. Okay, this is a relation. Now, if the relation looks a certain way, and here's another example of a relation. If the relation is such that there's only one x value, one unique x value for each of the pairings, okay, so that every x is only paired to a single y value. 1 is only paired to 8, 7 is only paired to 6, 2 is only paired to 1, and -3 is only paired to 6. If this is the case, then we have not a relation. Well, actually, it is a relation, but we can do better than that. We can call it a function. Notice that our focus is on the x values. Y values are allowed to relate to as many x's as they want. Here we have the 6 relating to the 7, and then a little bit later it relates to the -3. Look at that. Look at that. The 6 likes to get around a little bit. In a function, y is allowed to relate to as many x's as it wants, but only one x. Each x is only allowed a single y value in a function. Okay, so if we're listing out the points of a function or of a relation, and you want to know whether or not it is a function, what you want to look for is repeating x values. Okay, if the x's repeat, not a function. It's just a relation. Okay, and notice that I didn't even need to list any of the y values because we just look at the x's. All right. If we're looking at a graph of a function, then what we want to look at is, are there any x's that repeat in the graph? And to check that, we use the vertical line test, which says that at any point in the graph of vertical line can only touch a function at most one time. So if I draw it here, I hit the function only once. Only once. So this is a function. On the other hand, this is not a function, because right here I hit it 3 times. So this is just a relation. It is not a function. Okay? Now, for most of the math that we do, functions are a concept that appear all over in mathematics, even math that doesn't necessarily deal with numbers. When we get to, that's later on in college. For what we are doing, most of our functions that we are interested in are equations. Okay, and to be honest, most of the equations that you can think of offhand are functions. An example of something that is not a function is this is a circle, and a circle fails the vertical line test. Okay, so we have three ways to think about functions: as a list of points, as a graph, or as an equation. And it's the equation where most of the options you can think about are functions. If as long as you are not doing anything to y, you're generally okay as far as having a function or not. Okay, so let's shift gears and talk about the domain and the range of a function. The domain of a function is the list of all of the x values in that function. Okay? That's not a function. This is a function. Okay? So if I just list all of the x's, that's my domain. The range is a list of all of the y values in a function. Okay? Domain and range. We'll talk about the domain and range from a graph later in the next video. What I really want to talk about is the domain of a function written as an equation. Okay? So something like f of x equals 3x squared plus 6x minus 1, or f of x, let's call this g. G of x is x squared minus 6 over x plus 3, or h of x equals square root of 2x minus 1. Okay? There are two things that, here's what you want to think about when I hand you an equation of a function and ask you what the domain is. Your default is that it's all reals. Okay? Assume that the domain of a function is all reals. There are two things that you know about right now. There are two things that could change that. Having a variable in the denominator of a fraction. Okay, that could change the domain. Secondly, having a square root or any even root. Okay, these are the two cases that can change the domain from all reals to something else. So here, f of x, there are no fractions, no radicals. The domain is all reals because that's your default. That's what you start with. In g of x, I have a fraction. So look at the denominator, because this can never be 0. So what would x have to be for this thing to equal 0? And that's negative 3. So my domain is all reals except for negative 3, because that would put a 0 in the denominator. Okay? So if you have a variable in the denominator, this is what you do. Look at the denominator, figure out when it would equal 0, and take that out of the domain. All reals except for negative 3. Okay? If it is a radical, this thing under the radical cannot be negative. Okay? So this has to be greater than or equal to 0. And then solve that out. Plus 1 plus 1. 2x is greater than or equal to 1. Divide with 2, divide with 2. X is greater than or equal to 1/2. Okay? This is my domain, because I can't have any x's that would result in a negative number. Whatever's here has to be greater than or equal to 0. So the domain has to be 1/2 to infinity. I just turned this into an interval. Okay? So for the domain of an equation, assume that it is all reals, and these are the two things that would make you change your assumption. I'm over time, so we'll talk more about this tomorrow. Have a great evening, and I will see you later. Bye.